Welcome back on yet another episode on SRE Demystified. In this video, something completely different and something very interesting is what I am looking at. This is a case study by Microsoft on metrics to improve SRE at scale. I found this very interesting, not from the same textbooks that we have been seeing about SRE in the past videos. This is from an O'Reilly book on Seeking SRE by David N. Blank Edelman, and this is chapter 4, using incident metrics to improve SRE at scale, written by Martin Check of Microsoft. So what is SRE at scale? Whether your service is looking to add its next dozen users or its next billion users, sooner or later you will end up in a conversation about how much to invest in which areas to stay reliable as the services scale up. Working on SRE reliability on a variety of services ranging from startups to enterprise services all the way to cloud scale. So Microsoft has done a case study, and here they call it as a virtuous cycle. The full cycle key performance indicators, time from bug introduced to fix rolled out worldwide. So they call it as the deploy. The KPIs are time to deploy, build age, monitor, percentage of things automated, and time to detect, and then improve. There is TTM, time to mitigate, root cause analysis completeness, and then code where bug age, unit testing, coverage, repair depth, and then go back to deploy again. So the virtuous cycle created a framework that Microsoft could use to see how effective their monitoring was by how quickly they detected outages, how well they were learning from outages by measuring the root cause analysis process and repairs, and how quickly those bugs were getting fixed. They could then look at the code quality and deployment velocity to seek how quickly they would run through the full cycle. Important metrics. So some of the important metrics include time to detect, which is time to detect is a time from the metric start to the time that an incident is visible to an operator. So they start and counter when impact first comes visible to the customer, even if their monitoring didn't detect it. This is often same as the time that the service level agreement or SLA is breached. Then time to engage. This is a time from detection until appropriate engineer is engaged. This can be difficult to determine during the event and sometimes even afterward. It can be hard to look back through the fog of war to pin this down from a single engineer down to a single engineer. So it's okay to approximate with first engineer on the screen. And then time to fix. This is time that it takes the responder to mitigate the issue. And from all these we can determine TTD plus TTE, time to detect plus time to engage plus time to fix, is nothing but time to mitigate, TTM, the full cycle time through the outage. So you can see here, time to detect is minimized with automated monitoring and alerting to protect SLA, and then time to engage can be minimized with automated escalation and solid escalation process, and then time to fix can be fast rollback, failover, fix forward, and then a key role that is played in all these places is SRE Matrix dashboard that shows sum up values of various parameters of interest. In this example, time to detect, time to engage, time to fix, time to mitigate, everything, and percentage of outages detected. So this really gives the top management an understanding of what is a trend, what is a goal, how many times we met the goal, etc., etc. And then surrogate metrics. If you look closely at the SRE Matrix dashboard, you will notice a few metrics like direct responsible individual. You can see here DRI, the direct responsible individual hops, X, Y, etc. So hops, call engineers are needed to resolve an incident, and auto detection, how many incidents are detected via monitoring. These are surrogate metrics, which are submetrics related to the top level time to metric like TTD and TTM, that are more specific and actionable than the high level metrics. But they themselves do not indicate a success or failure. Using surrogate metrics lead to faster, more durable improvements, because giving engineering managers specific action items and submetrics is a very effective way to drive actions than just telling teams to do better and try harder. Another key term in this case study is repair depth. So they say repair items are technology or process fixes that either prevent an outage from recurring or reduce its duration. Typically, these are broken down into short-term terms and long-term items. Short-term items and long-term items. The short-term item should be rolled out quickly, maybe within a week, and might be a process, a script, or a hotfix. Long-term are things like you need more thorough code fixes and may take several weeks to months. Or maybe you want to build a chatbot for auto escalation, anything of that sort. So tracking repair items lets us incorporate operational depth into standard engineering process and treat it just like feature work. So you can see a good example when it happens when begin tracking the repairs. There is usually an initial spike in depth as we start to expose previously unknown or unfocused repair actions, and then it slowly comes down and stabilizes. Finally, there is one more term called virtual repair depth. So not every movie has a Hollywood ending, and we found that not every service saw the fruits of repair items rigor. In some cases, even though repair depth was stable, the reliability month over month wasn't necessarily getting better. This brought about a new challenge: how we can measure the quality of postmortem. So not only do we need to measure whether repair items were getting fixed, we also need to measure whether they were getting created in the first place. Most postmortems include a lot of text describing the problem and what was done to mitigate. We could certainly apply some machine learning and artificial intelligence concepts to the text and try to parse out intent, but that would take a significant investment and would not be deterministic, isn't it? So the simplest solution was sitting right in front of us all along in the front in the form of time to metrics that we attach to every incident and every postmortem. Any incident that missed a time to detect, engage, or mitigate goal should have a corresponding repair item. This means we had to have a taxonomy of the repair process to attach engagement, diagnosis, and detection flags, so we can programmatically extract missed repair items. We then used it to measure repair items, and what Microsoft call it as virtual repair depth. So visualizing virtual repair depth become a powerful tool to drive improvements. You can see in this picture how it looks like. The gray line representing repair depth makes it look like the team is keeping up with the repair depth. But when you add to the dotted red line that represents missed repairs, that is growing, right? The dark matter repair items, the form virtual depth, become glaringly obvious. So virtual depth is particularly important because it represents the corpus of repair items that were never logged, and will end up hurting the service down the road. When there is virtual depth, the specific TTD and TTM misses will repeat over and over until they are logged and fixed. So I hope you like this case study. There are a lot of further reading that they suggest. Until we see a beautiful episode on SRE again, thank you. Bye.